Assalamualaikum warahmatullahi wabarakatuh, and a very good day to my beloved software integration lecturer Dr. Juliana Jaafar and all my friends. Today, I would like to share with all of you about my video titled Design Pattern Detection Using Similarity Scoring. This title categorized under topic 4, which is Design Pattern. First of all, what you need to know is the identification of design pattern as part of the re-engineering process can convey important information to the designer. However, existing pattern detection methodologies generally have problems in dealing with one or more of the following issues. First of all, detection of modified pattern version. The second one is search space explosion for large system and extensibility to novel pattern. In this paper, design pattern detection methodologies is proposed based on similarity scoring between graph vertices. Due to the nature of underlying graph algorithm, this approach has the ability to also recognize patterns that are modified from the standard representation. Next, we go to the introduction. Design patterns are generally defined as description of communicating classes that form a common solution to common design problem. Most software project deals with evolving product consists of a large number of components. Their architecture can become complicated and quite messy. The identification of implement design pattern could be useful for comprehension of an existing design and provides the ground for further improvement. In the proposed methodology, both the system under the study as well as the design pattern to be detected are described in terms of graph. For the detection of patterns, we employ a graph similarity algorithm which takes as input both the system and the pattern graph and calculates similarity scoring between their vertices. Okay, in the article has stated some major advantage. What we can see here, the article highlight the major advantage is the approach of the ability to detect not only the pattern in their basic form, the one usually found in the literature, but also modified version of them, which is given that the modification is limited to one pattern characteristic. This is significant prerequisite since any design pattern may be implemented with myriad variation. Next, article also highlights some important challenge where one of the most important challenge in pattern detection is the size of exploration space for large software system. Okay, next we will go to the okay, the Application of the above-mentioned similarity algorithm to the entire system will lead to efficiency problem due to the slow convergence of the algorithm. So, the similarity algorithm is applied to smaller subsystem rather to the entire system. The proposed methodology has been evaluated in JT-Hot-Raw, J-Refactory, and JUnit, which are open source projects extensively and systematically employing designing pattern. The result has been validated against internal and external documentation of this system. For the design pattern that have been examined, the number of false negative was limited, while false positive have not been found. According to the result, similarity scoring is resistant to such kind of modification since it correctly identified those instances of pattern. Okay, what we can see here is an example of structure of decorator design pattern. Okay, the similarity scoring algorithm. First, we see it in theoretical analysis. Okay, first we see that Kleinberg proposed a link analysis algorithm for identifying pages on the web that are authoritative source on board search queries. The rationale behind this algorithm is that the quality of a page P referred to as the authority of the corresponding document is not related only to the number of pages pointing to P, called hubs, but also to the quality of these hubs. Hubs and authorities exhibit what could be called a mutually reinforcing relationship. Blondel also proposed a generalization of the concept of authority and hubs and formulated an iterative algorithm for calculating the similarity between vertices of two different graphs. Let GA and GB be two direct graphs with respectively NA and NB vertices. The similarity metric S is defined as NB time NA metric where real entry Sij express how similar vertex J in GA is to vertex I in GB and is called the similarity score between the two vertices. The algorithm used for calculating similarity metric S is shown below. Okay, what we can see here is set z0 is equal to 1, iterate an even number of I times. Okay, you can see the formula there and stop even convergence. Output S is the last value of zk, where AB are the adjacent metric of graph GA and GB respectively. Z0 is an NB times NA metric filled with 1. So, the convergence refers to the subsequence of even iterations. Next, we see the similarity scoring algorithm in terms of graph matching algorithm. We can see in graph matching algorithm, we have two, where exact and inexact graph matching algorithm. First, exact graph matching algorithm, where the problem is to find a one-to-one mapping, where is isomorphism between the vertices of two graphs that have the same number of nodes, that there is also a one-to-one correspondence between the related edges. In exact graph matching algorithm, which apply when an isomorphism between two graphs cannot be found and aim at the best matching between the both graphs. Okay, we can see the example here. Okay. Okay, here we have the representation of pattern structure as graph and matrix. We have association graph, association matrix, generalization graph, and generalization matrix, abstract class graph, abstract class matrix, similar abstract method invocation graph, similar abstract method invocation matrix. Okay, based on this, there's two advantages of this approach where one, the matrix can be easily manipulated. Number two is this kind of representation is intuitively appealing to engineers and computer scientists. Okay, the similarity algorithm does not depend on the specific types of metrics that are used. The designer can freely set as input any kind of information provided that describe the system and the pattern as matrices is term of the information. Okay, next, here are the UML class diagram of two system segment and a design pattern. Okay. Okay, here's are the example. Okay, let we assume that the system under study has two segments represented by the corresponding class diagram. This pattern is known as the redirect in family elemental design pattern, which form a part of the well-known decorator and composite design pattern. Obviously, the class diagram of segment 1 is a modified version of the design pattern containing an additional inheritance level. On the other hand, the class diagram does not form a pattern since it only consists a simple hierarchy of class. Figure represents the class diagram as graph, where one for associations and one for generalization. And in exact matching algorithm that will consider and edit distance measure will conclude that the class diagram of segment 2 is closer to the pattern. That is because to obtain the graph of the pattern from the corresponding graph of segment 2, only one edit operation is required. One edge addition is the association graph between edges B and A. On the other hand, to obtain the graph of the pattern from the corresponding graph of segment 1, 5 edit operations in total are required, where generalization graph, deletion of edges BA and CB, deletion of node B, the addition of edge of C and A, association graph, deletion of node B. Consequently, any generalization relationship between two classes will be considered as a strong candidate for the pattern, while the modified version of segment 1 will be considered a rather weak candidate. On the other hand, the similarity algorithm produces more accurate results for the same example. The similarity matrices between the corresponding graph of segment 2 and the pattern are the similarity function correspond to the similarity algorithm described. Okay, next. Okay, here are the solution for more understanding. The sum of two matrices you can see there, and while the normalized score eventually highlight similar nodes calculate. Okay, where K1, K2 correspond to the number of matrices which pattern row 1 and 2 are involved respectively. In this case, both rows are involved in the association of generalization matrix, the similarity matrix between the corresponding graph of segment 1 and the pattern, the normalized scores, the solution. The handling of multiple inheritance. Hierarchy 1 and hierarchy 2. The methodology. First, the reverse engineering of the system under study. Each characteristic of the system under study is represented as a separate n times n adjacency metric where n is the number of classes, detail on which abstract information will be discussed in the implement section. Detection in inheritance hierarchies. All kinds of generalization relationships are considered for building the inheritance trees. Construction of subsystem matrix where the subsystem is defined as a portion of entire system consisting of class belonging to one or more hierarchies. Next methodologies is application of similarity algorithm between subsystem matrix and pattern matrix, where normalized similarity scores between each pattern role and each subsystem class are calculated, and extraction of pattern in each subsystem. Usually one instance of pattern is present in each subsystem. Optimization have been applied in order to improve the efficiency of pattern detection process, where minimization of number of roles for each pattern, exclusion of irrelevant subsystem. The limitation. Manual code inspection by the author could pose a threat to the validity of empirical evaluation, possibly affecting the number of false negatives. As already mentioned, there are patterns whose detection is based on the identification of a specific sequence of action. For the reason, the description of such pattern is usually accompanied by sequence diagram. The conclusion. The detection of design pattern is a software system which is an important task in the re-engineering process, exploiting only UML diagram and designer's experience, in which very difficult in the absence of automated assistant tools. The main contribution of the approach is the use of similarity algorithm, which has the inherent advantage of also detecting patterns that appear in a form that deviates from their standard representation. Okay, let us let me introduce the writers for the beneficial article, where Nikolaus Tsantalis, Alexander Chatzigelgel, George Stephanis, Spiros Tihalkidis. The end. Thank you. Assalamualaikum warahmatullahi wabarakatuh.